Alrighty, now we're going to take a look at some more horizontal stretches. Again, it's like taking a string and pulling both ends. First, we're going to look at f of x equals 1/5 x quantity squared. Actually, you know what? Let's do 1/4. Okay, so f of x is equal to 1/4 x quantity squared. So here we have x squared. We're going to make b equal to 0.25. And we can see that it really widens. Okay, now if we make b equal to 0, that's a whole other story. It's actually not technically a transformation, but when b is 0.25, you can see the u really becomes more rounded, like a bowl from the original. So the smaller that fraction becomes, or the closer that fraction becomes to 0, so 1/4, 1/8, 1/10, whatever, or the smaller that decimal becomes, closer that decimal or fraction becomes to 0, the wider this graph is going to be. I can't do those other, let's just do sine and cosine of 0.2. Sine and cosine of 1/4 x. So here's sine. Let's do sine of 1/4 x, and we can see that it really stretches out. Yes, really stretches out when you make it 1/4. Let's try not to go to 0 this time. Almost becomes a straight line. Same thing for cosine. So the smaller that decimal becomes, the closer it becomes to 0, the more these functions are going to stretch out. This is the exact same proof as we did with shrinking. Therefore, I'm really not even going to explain it again, except this needs to be a b. Okay, it's the same exact proof, but what it demonstrates is that you still divide you take the original x value and you divide by b to get your new transformed x value. And if you plug it back in, it yields what's required. Again, I've already done that proof in horizontal shrinking, so watch that video first. You're going to start out with the same parent chart. You're going to end up dividing by b to get your new x values. Now again, since b is a fraction, you can always multiply by the reciprocal, 1/b, but it's just helpful no matter what b is, whether it's a fraction or a whole number or whatever, you always take your original parent x values and you divide by b to get your new transformed x values, and your parent y values will stay the same. They'll be the same for your function y values. And this will be your function, your transformed function chart. Just like we did with horizontal shrinking, it's the same for horizontal stretch. Now when we read the rule, it's a little bit different. When f of x is equal to p of bx and the absolute value of b is between 0 and 1, so even if it's like a negative fraction that's between 0 and 1, so let's just make this negative 0.25, you can still see it stretches. So even for negative 1/4, it still stretches. So when the absolute value of b is between 0 and 1, then the parent graph p of x will stretch by a factor of 1/b to reach the transform graph. So for example, for 1/4, it would stretch by 4 because 1 divided by 1/4 is 4. So it's going to stretch by the reciprocal of the fraction to reach the transform graph f of x while keeping the same y value or p value. Therefore, the horizontal stretch will be 1/b, and p of x will stretch by a factor of 1/b to reach f of x. That is horizontal stretching in a nutshell. If you have any other questions about horizontal stretching, let me know.